A very good afternoon to respected teachers and my dear friends. This is Group 17 and the topic of our project is Document Analysis and Understanding Answer Sheet Scanner. We are doing this project under the supervision of Dr. Gitanjali ma'am and I am Vinjit.
Myself, Mohit Boja.
And myself, Sujit Kumar.
So these are the outlines for our presentation. The first one is introduction, second one is problem statement and objective, proposed architecture, proposed methodology, pseudocode, results, comparison with traditional method, tools, hardware, software, and programming language to be used, contribution, target for next semester, and references. So the introduction for our presentation is handwritten character recognition is the field of research in artificial intelligence, computer vision, and pattern recognition. Our field of study in document analysis is to make an answer sheet scanner for educational institutes to recognize handwritten text answer sheets and display them in a computerized field data. The computer performing handwritten recognition is said to be able to acquire and detect the character in paper documents, pictures, any devices, and other source which can create connect to the machine. Our project will easy workload to teachers across all the department of our institute by completely automating the system for manual entry of the marks into the answer sheets. Motivation for our presentation is the fast development in worldwide technology makes it essential for us to find solutions for some challenging problems. One of these is the recognition of the important details from the images. In recent years, there have been growing interest in digitization of the depth amount of books document that exercises illustrating the widespread adoption of the digital technology. Major motivation for this project is in present era of technology, automation is very important as it reduces the time required for manually computing and typing data. It also reduces typographical errors. So these are the literature review. We have read a lot of research papers, and from them these three are the basic review papers. The first one is a technical review on text recognition from images. This review paper is from the Pratik Madhukar and Dr. Kavita Asing. According to this review paper, this paper method document is generally scanned the optical scanner and is converted into the picture, and then the data is analyzed then the data is analyzed from the device. The project model is based on different forms of handwriting. As we know, there are billions of handwriting available, so it's a challenging task for us to fulfill all the requirements of different forms in the printed text. What is the disadvantage of this paper? It does not emulate actual handwritten text from the images. It is basically for only the printed text. So as we know, our project is basically on the handwriting. So as we know, text recognition is an active process, and there is no perfect software which is available for all the fonts in the page may be different for text. The second literature review is the text recognition from images. This is again by Pratik Madhukar and Shashank H. Yadav. According to this methodology, there is a need of character recognition system to perform document image analysis (DIA), which changes records in paper plan to electronic arrangement. Nowadays, there is a special interest for putting away the paper into a PC storage disk and afterward using the data by searching process. The disadvantage of this review paper is that the challenging involves in this is the quality of picture and textual styles quality of the character in paper archives. Because of these difficulties, PC cannot perceive the character while reading them. It also does not scan the handwritten text due to the different variety of handwritten fonts available in the world. The third literature is from text detection and character recognition in seeing images with unsupervised features. The writers of this review paper are Adam Kautz, Black Carpenter, Tal Case, Sanjeev Satesh, Bipin Suresh, Tao Yong, David J. Wu. According to the summary and methodology of these, two major key segments of the most systems are content area for the pictures and character affirmation, and various progressive methods have been proposed to arrange better parts for depiction and model for both. We achieve attribution among the best known on the ICDR 2003 character acknowledgement dataset. In this paper, they apply strategy as of late made of AI, specifically algorithm for picking up the feature normally from unlabeled data, and demonstrate that they empower us to construct significantly amazing classifier for both discovery and acknowledgement to be used in high precision end-to-end system. So the disadvantage of this review paper is reading text from photograph is a very challenging task for us. That has received a lot of attention recently. As in quite a bit of PC vision, the problem presented by the unpredictability of these pictures have been battled with unstructured analysis models that join different bits of significant level earlier information. This is the comparative study between all the three papers which we discussed previously. So gaps in the existing systems are most of the approaches are semi-automatic and require human intervention. As we know, there is no proper software available for handwritten recognition. If any available is either semi-automatic and require human intervention. Existing approaches show 70 to 72% accuracy for testing data and 80 to 94% accuracy for validation data. Recent work emphasizes the structural pattern analysis of document. Automatic digitization has not been investigated much.
Now come to the problem statement and objective. Developing answer sheet scanner using handwritten recognition, process by using different types of algorithms and techniques in Python. Answer sheet scanner will scan the answer sheet of students, recognize the useful information, for example, marks obtained by the students, and save it into the computer in digital form. Now come to the objective. The objective of this project is to automatically record the marks of the students and store it into the computer system. Now come to the proposed architecture. Architecture contains total 8 steps. First one is input. In input, we generally input the JPG image to the system. Now come to pre-processing. The aim of pre-processing is an improvement of the image data that suppresses unwanted distortions and enhances the some features of the image that helps in further processing. Now come to the image segmentation. Image segmentation is generally segments the image into different image objects and set of pixels. If we have image into large pixels, then convert into 28 into 28 pixels. Now come to the feature extraction. Now come to the feature extraction. Feature extraction, a type of dimensionality reduction that efficiently represents interesting part of an image into a compact feature vector. It is useful when image size are larger and a lesser image size are required to quickly complete the process like image matching and image retrieval. Now come to the feature measurement. Feature measurement. In this step, we generally measure the feature of the image that comes from the feature extraction phase. Now come to the classification. The objective of image classification is to identify and portray as a unique grayscale the feature occurring in an image in terms of the object cognition. Now come to the recognition. In this step, we generally recognize the interested area from the answer sheet. For example, marks obtained by the students. Now come to the representation. This is the last step, and in this step, we generally store the information into file or database in the system. Now come to the proposed methodology. In this problem, we have 10 levels, so it is a supervised learning. 10 levels means 0 to 9 digits. Since we recognize the digits of the marks like 5, 1, yeah, 8, 9, yeah, 3, 7, etc. The problem of handwriting recognition is a classification problem, as we have discrete levels 0 to 9. We could not use logistic regression because we know that logistic regression is best suitable for the binary classification, such as if answer is in the form yes or no or in 0 or 1. But in our case, we have 10 levels, so logistic regression will be expensive in our case. So we use neural network or especially CNN, convolutional neural networks. That is far better than logistic regression, and its performance is also better than logistic regression. This is the representation of the CNN, convolutional neural networks. Left side circles represents the input layers, and the middle circles like cyan color circles and green color circles, it's the hidden layers like hidden layer 1, hidden layer 2. Hidden layer as per the requirement of the problem, and the rightmost circle represents the output layer. Here we can see that from just few features we can create lots of parameters. Number of parameters equals to number of connections in a neural network. So our model becomes more powerful and the probability of correct prediction increases.
So like I said, myself Vijay, and from what Sujit, my friend, said, I'm continuing it. Basically, this on the left side, this is a 28 cross 28 image. Let's suppose it is a bit skewed, but let's consider it as a 28 cross 28 image. And as you can see, the x1, x2, x3 are the pixels 3 by 3 cross 3 pixels from x1 to x9. It is our patch file, basically a filter type thing, which will we will stride across the image for the entire 28 length in the rows wise, and then come down and then again do that till the end. So basically, on the right side, you can see how our filter looks like. And Z is our ReLU function, which is a linear combination of both. Like if we put the patch on this image, then we get x1 w1, x2 w2, x3 w3, and so on. And we add a bias value, which we have taken as 1 in our entire project. So we have used ReLU activation function, and this is the basic feature extraction process we have described over here. Now this is how the patch is applied and how the tensor is built. We have, like on the left side, we can see that 28 cross 28 image, and the depth of our image is 1 because it is a 2D image, and we are putting 3 cross 3 patches. Actually, we are putting 32 patches initially, so we can see from 1 to 32 we are putting 3 patches. And if we come back, we can see that when we stride the entire patch across the 28 across 28 image, then actually we get 26. Because the size is 3 and at the last there will be 2 remaining, so that will be 26. So we get 26 cross 28, 6 cross 1 for the first patch, then for the second patch, third patch, in the same manner, we get 8 for the entire 32 patches. So on the right hand side, you can see how the 3D output is built from these all the 32 patches which we use. Now we after that we use dense layers in our neural networks to flatten it and get the 10 labels which we require. So this is the basic process of our project. First, we are getting the input image. Then we are doing a convolution. We are adding a convolutional filter. I will basically explain everything. I will explain it in the implementation part, which I will show you further on. So first, we are adding a convolutional filter, a 3 cross 3, and striding it with 1. We are putting a stride 1 for our filters, and we are doing pooling. Pooling is done to do the downscaling of our parameters, and so we are using the pooling, and it has a stride of 2, and the pooling for which we are using 2 cross 2. So first, we are using convolutional filter. Then we are doing max pooling. Actually, there are 2 types of pooling: average pooling and max pooling. We are using max pooling over here. So then again, as convolutional filter, second time, you can see how the dimension is getting reduced by half. Then after that, we will come for the next max pooling. We are downscaling again, and again as filter is added. So in the left side, you can see how many parameters we are getting. We are having 32 parameters, 320 parameters, because 32 into 3 cross 3 plus 1, and it is increasing for every filter that we add. For pooling, the parameters does not contribute. The pooling does not contribute to the addition of parameters. So this is the pseudocode of the program, which I will show you in just 2 minutes or 3 minutes time. First, we are doing the character recognition process using MNIST dataset. In the bottom side, you can see how I built the convolutional layer and doing the max pooling. After the pooling, we are doing training our model for 5 epochs or iterations, we can say. Now, after that, we are recognizing this segmented image one by one. We actually have to run a loop to recognize every segmented image. And basically, I will show everything practical after the end of this PPT. The result, this is a basic summary of our model. We are getting 90,000 plus parameters in our model, and it basically again describes the convolutional filters and the convolutional layer adding process and the max pooling process. So this is the training and testing output which I am showing on the screen. Basically, you can see the accuracy after the 5 epochs is 99.36 for the 60,000 training images which we have on the MNIST dataset, and for the 10,000 tested images, we get accuracy of 99.15%, which is very good as compared to the previous models, as compared to the traditional model basically. So this is the output of the segmentation process, which we can see that contours are built across over every digits, which is shown in the pink color. And when after converting it to grayscale, you can see the image of 8, how the 8 is shown, and the output which we get 8. So I will show you entire in the implementation later on. So this is a traditional model which I built using feed-forward neural network, and you can clearly see after 5 epochs we get 97% accuracy for training images, and for testing we get 97.5%, which is doable but less than CNN model when compared to CNN model. So in the traditional machine learning, we use the feature engineering and computer vision libraries. We do feature extraction process and all, but in CNN it is getting replaced, and CNN basically generates the features automatically. And as I told you in the starting part, how the how the filters are striding across the images and collecting the features. So when we train using CNN, it relieves us from the expensive and tedious task of feature engineering task, which is required in traditional machine learning algorithms for handle network. In feed-forward neural network, we got more than 1 lakh parameters, but in convolutional neural network, as I showed you, we got 93,300 parameters approx. So despite having more number of parameters, feed-forward neural network gives lesser accuracy as compared to CNN model. These are the tools, hardware, software, and programming language to be which we used for building our model. We use Python, Anaconda Navigator, or Jupyter Notebook because we have to create a great document as well. Spider, which we use for programming some of the codes. Google Colab is a free service provided by Google, and the main thing is that we do not have to get high-end laptops for that because some of us do not have the laptops having GPUs and all. So Google provided it using Colab. So we have that features, and the libraries which we use were NumPy, Matplotlib, and all. So that's all, and we have done entire programming in Python language. The tools and hardware which we use include high-end processor, Windows-based OS, and a high-resolution camera. So the contribution basically, all three of us have contributed equally towards this project. My friends Sujit and Mohit have done their own parts. All three of us read equal number of research papers, and our research work is also getting published in ICCSP 20, which got postponed due to this COVID-19 situation. Our supervisor, Dr. Gitanjali ma'am, helped us a lot and guided us a lot through the entire process of this model creation. So the target for our next term would be to recognize the area of interest from the answer sheets and deploying that system in our department. These are some of the references. Now, let me show you how, the implementation part. So this is the segmentation process which we are doing right now. We are doing it using the OpenCV method, and as we have seen the contours which was found in the segmented images, we have to calculate the minimum the contour comprising of the complete single digit. So that it is the function for this, and this is to get the coordinates of those rectangular boxes. Now in this cell, I am retrieving a string and saving it in an image. And actually, this string contains my roll number, and I am breaking my string into single digits and storing it in the form of MNIST. As since our our model has been trained and tested for MNIST dataset, so we have to convert our string into that format. So after that, we are storing it in this location. So I will come on to this location. So this was the location where we stored it. So this was the string for which we tested our data. So this is the string which I was talking about containing my roll number, and these are the extracted images. First, our extracted images looks like this, and after converting it to MNIST form, that is 28 cross 28 pixels, it looks like this, 51810062, and I have sorted it according to the x-axis, so it is in this sorted format. Now, after the extraction process, we get the successful extracted notice. So now we pass this onto our model build. So first, let me explain our model. We are making this model using TensorFlow and Keras. These we are importing some of the libraries which we generally use. First, because since CNN take 4D tensor and images are 3D tensors, we have to convert. We have to reshape it. So the reshaping is done over here. Then we are creating the convolutional base and adding the convolutional layers. As I told you in that flowchart, the 32 filters of 3 cross 3 and max pooling of 2 cross 2. We are doing the entire process here. We are adding three convolutional layers and 2 pooling. And after that, the model summary is shown here. And after the adding the dense layer, we are getting this output. Actually, in the end, we are putting 10 because we have 10 labels, 0 to 9. So this is the output there, and we are getting the 10 labels. After the training for 5 epochs, as you can see, our accuracy is 99.76 for training, and for testing it's 99.01, which varies sometimes due to the randomness of the images taken in training and testing. After this is the code. I am actually doing it for a single number. This is 5 achievement passing. You can see the array, and the array having the fifth index would be 5, like 0, 1, 2, 3, 4, 5. You can see this is the largest. So this is getting printed over here. So this was for the single digit, which we got 5. Now we can try it for the entire string, 51810062, and there are 8. So I will get all the strings one by all the images one by one and do it. So after that, the string printed is 51810062, as you can see in the output. So our model is quite accurate and is very efficient as well. So we are so this was the classification we are doing using the feed-forward neural networks. The flatten layer, and you can see the parameters is more than 1 lakh, which I told in the earlier presentation, and the accuracy is pretty low as compared to the it is 99.06 for training and 98% for testing. It is doable, but since convolution provides more better accuracy for less parameters, we will prefer CNN. And this also gives us the same output. That is my roll number. So that's it from our side. Thanks and have a nice day.